Okay, good afternoon, everybody, and welcome to our webinar this afternoon, where we're going to be taking a look at how smart PV solutions for high power modules can reduce the levelized cost of energy in PV projects across the world, but specifically here in Asia. We've got a fantastic panel joining us today who are now just all turning on their screens, but just while they get themselves sorted. My name is Paul Clark and I am the General Manager for Terrapin here in Asia. It's my pleasure to welcome you here this afternoon. Just before we get started, a couple of very quick housekeeping points. First of all, I would remind you that the opinions expressed by our panelists this afternoon are their own and do not necessarily represent those of their organization. So please do bear that in mind. And the other thing is that we really want to hear from you during the session. So if you've got a question that you'd like to ask our panelists, please do feel free to do so. It's very easy. All you need to do is click on the Q&A button, which is very helpfully labeled Q&A and looks like two speech bubbles talking to each other. Once you do that, you'll be able to type your question in there and then the panelist will get to it, time permitting, as we go through the session. So really all that remains for me to do is to introduce this afternoon's moderator to you, Christoph England. He's the Managing Director at Energetics here in Singapore, and he's going to be taking you through today's session. So Christoph, I'll hand over to you.
Oh, thank you very much, Paul, and good afternoon, everybody. I presume it's your afternoons. Thanks to this webinar online, we can bring people from all around the region at a great reduction in CO2 emissions. So we've got people from Australia, China, Malaysia, and Singapore. I'm cheating a little bit. My background shows you Switzerland, but I'm actually in Singapore. So I would like to start off by asking each panelist to introduce yourself. Just the basics, and also answer one simple question, because COVID's the main reason we're doing all these by webinars instead of in the flesh. So has COVID resulted in more or less demand for solar equipment? And in which regions do you see the biggest change? Maybe starting on the top left there, Andrew, can you kick off?
Yeah, thanks, Christoph. Hi, everyone. Good to be with you. So I'm Andy Gilhooly. I manage Trina's utility solution sales business in the Asia Pacific region, known as TrinaPro or Trina Tracker. We are active in many markets in Asia. I'm based in Melbourne, Australia. So very focused on the Australian market, but we're also participating in India, Malaysia, Vietnam, all the way over through Central Asia and into Israel as well. So a pretty big patch. Been in the solar industry for 13 years now, and either designing and bringing to market or selling single axis trackers for 10 of those 13 years. So it's a subject that's quite close to my heart. So I guess to address your question as well, yeah, what a year. It's been pretty challenging, not least being based in Melbourne under a hard lockdown while the rest of Australia emerged relatively unscathed. But yeah, them's the breaks. We're coming out of it now, so that's all good. I think, you know, we have seen a slowdown in Australia, but I think that's more to do with grid constraints and curtailment and so forth, rather than COVID. India seemed to take a considerable hit, at least in the utility segment, impacting, you know, migration and movement of workers to, you know, I'm focused on the utility segment, so that seemed to slow down the pipeline a fair bit. But hey, you know, it's really woken up at the back end of the year. Prime Minister Modi announcing 220 gigawatts by 2022, some crazy low bid pricing on some supersized projects. And we're seeing a real engagement now in single axis tracking, which is really encouraging for the business. Other markets, Vietnam's been a real rush towards the end of the year as the feed-in tariff deadline has loomed. And then Malaysia's been really good as well with the large-scale solar 4. So yeah, on the whole, it's, you know, it's been really busy. Maybe not quite so much getting over the finish line, but you know, plenty of pipeline continuing to grow.
Thanks, Andy. Lynn, the other side of Trina. Please, please give us your introduction.
Yeah, sure. Thank you, everyone. Thank you, everyone, for the time today to participate in this discussion. I'm Lim. I'm the head of product and marketing for Trinasolar in Asia Pacific. So mainly, you know, I'm supporting our clients in the region, you know, to bring about the new solar modules, new solar solutions to this region. So I've been in the industry for coming to 10 years. So I think it has been a quite exciting time to been through the ups and downs of the solar cycle, which we see the rapid changes that have been happening, especially over the last 1 to 2 years. And then with the COVID this year, I think things have also speed up quite a lot. So in terms of the market, I think my colleague Andy has already given quite a good overview. So I think, yeah, we will look forward to more discussion for this during this session. Thank you.
Great, thanks, Lim. Going clockwise, Mason, you're next.
Okay, thank you, Christoph. Hi everyone, I'm Mason from Huawei APEC region, and now I'm in charge of the whole solution team here in this APEC region here. And if you look at the market, yes, look at this year, 2020, it is very tough for everyone. But if you look at the future, of course, we're still waiting the solar industry will be very promising here, especially in the APEC region. And our team, our Huawei team, we are always focused on to support our customer to get a lower LCOE in their project, to make their project financially viable there. With our smart string solution here, in the utility, in the CNI, and also in the residential scenarios. So yes, if you have any further queries, I'm also looking forward to have a more detailed discussion with you guys here. Thank you.
Great, thank you, Mason. So that brings us to John from JG Lab, and then you'll also, after your introduction, start a brief presentation, yes?
Yes.
Yeah, go ahead then.
Hi, good afternoon, everyone. Of course, thanks, Christoph. I'm John, just call me John will do. I'm the head of renewable energy for solar segment for this whole ASEAN region. And I've been in the connectivity solutions business for more than 20 years, more than 20 years. And as for solar industry, I have close to 11 years of experience, especially for this ASEAN region. Coming to your questions, that you posted to us. I look at it, it's like this year, it is very unusual. And it is, everyone has been talking about the new norms, okay? At the very beginning of the year, when the pandemic struck the whole world, we were thinking of how this is going to pose a threat, including the solar industry. But fortunately, that the solar industry has been keep moving on. We are seeing a lot of installation happening, especially in this ASEAN region. And the business has been tremendously doing well in the solar industry. With the newcomer from Vietnam, everyone knows Vietnam is kind of like a hot cake, you know. We are doing very well in Vietnam as well, and it turned out to be the up and coming one, and we will see Vietnam to continue to prosper in 2021 and 2022 at least. This is what's happening in our region. Yes.
Very good. Thanks for that introduction. Are you ready with your slides?
Yes.
Yeah.
Sure.
Okay. I take it you've got the control of the screen to.
Yes, let me share my screen, and then I'll give a very short sharing with everyone here. Okay, let me just minimize this. All right, as I was sharing just now, my name is John, just call me John will do. I'm the head of renewable energy in the ASEAN region for JG Lab. So today, I'm just going to share with you guys a very short introduction on what does it mean by critical connectivity solutions for the solar systems. All right, I'll move on to very fast that there are many challenges at the solar system installation site. And particularly, we are looking at things like termites, rodents bite, you know, on the solar cable, the underground condition, the installation condition, that you'll be seeing things like this muddy vats and not well taken care of. And then we will have areas like, this is a very muddy installation site. I took it in Malaysia. This picture was taken in Malaysia, whereby the installation site is a very, it is common to have flood in the installation site for this particular project. So this is what we are referring to. And then we are also looking into connectivity threats, which we refer to things like crimping issue. You can see here this particular area that the terminal has been badly damaged due to applying the so-called the normal universal crimper. Okay, and then with this kind of crimping or so-called assembly tool, crimping tool, you will have issues like undercrimp, which you can see here under the microscope, that the terminal is not fully crimped, that you have some holes, some space here. And then you have also overcrimp issue, which you will see there is an ear coming up at this portion here. And with all this back crimping, your terminal, your connector housing, when you dismantle it, you can see things like this will happen. It started to melt, okay? And then moving on, if you use a thermal imager to inspect your installation, you know, before you start commissioning, you will see that your connectors of high heat has been imposed to the connector due to the back crimping. Then eventually, if these are not taken care of, we will be expecting something like solar fires, be it at the rooftop of the installations or the site that you are installing. Okay, so I don't go into the details of what we will offer. This is not the topic that we are discussing now, but of course there are solutions that we are going to address. Okay, so when it comes to be it ground mounted or for different conditions, site conditions, which you will have flooding or floating solar application, the different kinds of installation, it requires some know-how in terms of what good components you may need for your installation or for your application. And of course, some pictures on the rooftop installation, C&I projects. Then quality components that I've mentioned just now. These are the things that you may need to seriously consider when it comes to having a good connection. Using the right tool, the right components for the different applications. And for us, we also conduct connectivity technical workshops to educate our customer in terms of what would be the right SOP to follow in terms of minimizing the threats that you are going to pose to your installation. So we will share with the customers, the EPCs, the engineers, that what are the procedures you must take note while you're performing your installation at site. So we have been conducting a lots of site visits, and these site visits is actually conducted at the different countries in order to assist the customer to know better on how to perform a good connection. So that's all from me. Thank you. Back to you, Christoph.
Thank you for that, John. Very useful overview. And I think it's fairly common for people examining or looking at PV systems to focus just on the panels or just on the inverters and forget that the system is only as strong as the weakest link. Everything has to work well, has to be well installed by competent installers who know the right equipment and know the right tools. I've so often been shocked when I see, a subcontractor inexperienced just using a pair of pliers to crimp stuff. You know it's going to break. You know it's going to make a mess. Okay, let's move on to also some of the other panelists. I'd like to have this as a discussion. As in so many aspects of business and life, size matters. And now after years and years of the solar industry using a standardized roughly 6-inch cell, 156 millimeters squared, and a little bit bigger, 158, now we're seeing a step change in this conservative industry, going to much bigger cells. And I think Trina is one of the leaders in this change. So presumably you're doing it because it leads to lower costs. Maybe we can discuss how exactly that's leading to lower costs. Lim, if you could explain the advantages from your perspective of the bigger cells, and then also discuss it looking at rooftop systems, and we'll pass over to Andrew to discuss the relevance in tracking systems. Lim, please tell us about large cells. Why?
Yeah, sure. Thank you, Christoph. Yes, so I think the whole industry has been quite exciting, especially, in this year, we can see the very rapid changes in terms of the cell size that has been happening. So in the early part of this year, where 166 is still I would say, quite a standard offering. And then we see different suppliers coming up with the 182, and then now we also have the 210. So I think from Trina perspective, using a larger cell size is one of the most direct way to increase the power bin of the solar module. So when we look at it at system level, when the power bin of a single module is increased, so basically for a same size project, you actually will be using less number of modules for the project. So when the less number of modules is used, this will translate to savings in terms of the other BOS. And at the same time, I think for Trina design here, we are also going with the low voltage, high current design. So this will also help us to increase the number of modules per string, and matching with the inverters in the market, we'll be able to deliver this solution to our customer to help them achieve a lower BOS and a better LCOE.
Well, it seems they're trying to deprive you of some of your revenue by having fewer strings, less parallel. So you don't buy quite as many cables from John, but I'm sure he's not unhappy because you're still doing more projects in a sense. Thanks for that, Lim. What are the disadvantages? I mean, it's not easy changing from one format to another. There must be some resistance. People are skeptical. Where are you seeing perhaps some of the things to worry about?
Well, I will say that yes, because it's still a relatively new product, and because when we use the bigger cell, the whole module actually become bigger in terms of the dimension and weight. So this might be a concern, with some of our clients during the installation time. But overall, we do see that although the size and dimension is bigger, but the installation method remains the same. So it still is about some tweaking in the so-called the structural design, and at the same time also we can still use the previous kind of installation method to install the project. Then of course another concern that has been commonly raised out will be on whether the high current of the module is at any risk. So I think along the way there has been many seminars and many discussion to convey and also educate the industry on how we can mitigate the risk of high current. And I'm sure our inverter friends are also upgrading their inverter models that is able to accommodate this kind of high power, high current modules.
Great. Okay, we'll come to the inverters in a moment. Andrew, what do you see as the main challenges in integrating large format modules with single axis trackers, and how do you overcome those?
Yeah, so I think first and foremost, the wind load. The trackers have been around for decades, but really it's only been in the past 5 years, I would say, that the industry has really gotten to grips as trackers have got to, multi-gigawatt scale year on year, and the comprehension has improved and matured. Historically they used building codes, which are wholly inadequate for, statically indeterminate structures like single-axis trackers. And trackers rarely fail in their peak wind speed. They're normally fail when we do see failures in the field of other types of trackers. It's normally from at a lower wind speed from these kind of dynamic effects. So it's a highly complex question and not really suited to these kind of one-size-fits-all national building and wind codes. When we consider or compare trackers to fixed tilt structures, normally on fixed tilts we see 2 piles, one fore and one aft, and each end is basically linked longitudinally, so it delivers a really stiff structure, and well retained and affixed at every corner basically. Now, by their very nature, trackers have to rotate around an axis as they face the sun to boost the yield. So you have these 2 big cantilevers and unsupported weights at both ends. There's a much greater propensity to suffer from these second order dynamic effects like galloping, instability, and fluttering and so forth. So
that's when the whole thing starts to vibrate. Is it like those bridges in the wind, famous pictures?
Correct. Okay. Yeah, and it's more, there's a little more involved than the bridge example. There's things like vortices forming under turbulent wind flow, and if these vortices form and are dissipated at the same natural frequency as the structure, that's how you can really get into serious trouble. Aside from that, that's only really been that's been exacerbated by, as we say, the module form factor getting larger, and especially longer, right? So, our 550 watt modules are now almost 2.4 meters long compared to around about 2 meters. So that's an increase of 20%. As you may or may not be aware, wind load increases non-linearly with height from the ground. So in order to avoid the modules colliding with the ground, the tracker structures have to be a bit higher, and accordingly the wind loads going into it increase. And not just the modules, there's been a few industry developments that have really created this perfect storm for tracker design. Also things like in longer string lengths. So as Lim was saying, we can run up to almost 40 modules in a string with our low voltage modules compared to 30 or fewer with conventional approaches, because there's fewer cells in our modules. As the industry's gone from 1,000 to 1,500 volts, strings get longer. There's the longer the tracker gets north to south, the more of this kind of twisting propensity you can get from these dynamic effects. Other things, the trackers all used to be with a single module in portrait. Now about a quarter of the industry is going to 2 in portrait, so that basically doubles your chord area or the width of the tracker. Again, increasing the height from the ground and really exacerbating these dynamic effects further. We're also deploying trackers on, trackers only really used to be deployed on easy sites, pancake flat, no variability in the terrain. And as tracking slope tolerances have increased, and sites become harder to deploy upon as the easier sites are depleted, we're seeing more sites becoming increasingly challenging in terms of terrain and topography. That can also exacerbate the wind load. So there's a number of effects here, all compounding. So really what's needed is a multidisciplinary approach to validating these aeroelastic effects in a kind of 3-dimensional perspective. So it's very highly complex. Lots and lots of computer, computational fluid dynamic modeling, finite element modeling, and so forth. But you can't beat real life wind testing, right? So really, it's a must that you have to engage with industry leading wind consultants. As a company, Trina engages with RWDI as one of the leading wind consultancies and invests very heavily in the wind tunnel testing. But it's an investment, right? We have to ensure our trackers are fit for purpose and are going to hold up over the long term. But there's also a benefit there where we understand the dynamics going into the structure, we can optimize the material usage in terms of sectional thickness of the metal. We can maybe reduce some of the piles, so there's fewer piles to physically install. We're down as low as 120 piles per megawatt now, and trackers used to be, you know, 300 to 400 piles per megawatt. So
wow.
you've got rocky sites, and you may be pre-drilling every pile or every other pile, and concrete's not cheap, right? So that's you know, that all these things can have a really marked effect on reducing your CAPEX and LCOE. But you've got to get wind tunnel testing right to have a firm foundation to build upon, as it were.
Okay, well, I know a lot of our audience, I see from the Q&A here, is in the Philippines, where they do have fairly strong winds. So maybe we'll see what opinions come from there. You mentioned one of the last big changes in the sector, which is when the PV modules went from 1,000 volts to 1,500 volts. And it took a long time coming through, because it's no good having 1,500 volt modules if you don't have 1,500 volt connectors, inverters, cables. Everything has to be specified for that. So now, Lim also mentioned this, and I'm going to address the question to Mason about the challenge you have with higher currents, and how does that affect the inverters with the maximum power point trackers. You know, can you now still put 2 strings in parallel per MPPT input, or is you constrained to 1? What are you guys doing in Huawei to adapt these new large cell modules?
Okay, thank you, Christoph. Yes, talking about our inverter, this kind of technology, how to accommodate the large current modules there. It is really project by project there, case by case here. If we are talking about some project, which is the overloading of the inverter, the project, it is lower than, like, for example, 20%. Still, you can connect this 1 MPPT with 1 string only to match the overloading requirement here. And because for the last current modules, which means the current is higher, but the open circuit voltage, it is lower, where we can make a bigger string size. For example, we can connect 36 to 40 modules in series in 1 string there. It depends on the project location, the temperature there. So in this case, if the overloading below 20%, we can connect 1 string there. But for some project, if the overloading requirement is more than that, for example, like for example, in India, in Vietnam, it is 40% to 50% overloading requirement. In this case, we have to, yeah, this is a ratio here. This is a overloading here. So then in this case, we have to design an inverter with a bigger, larger MPPT current to accommodate the large current modules here. So yes, we are launching the new inverter model in Q1 2021 to address this challenge here.
Okay, thanks. So that means we've now got the modules coming out in larger format, the inverter manufacturers, at least Huawei, coming up very quickly with products to match. John, what sort of common mistakes are made in solar connectivity? You showed some slides and stuff. Some of those were accidents due to inexperience, but where can the biggest gains be made, let's say, by doing the job properly?
Well, when it comes to solar installation, majority of the players here in wherever they are, most of them, they have installed at least in megawatts. We are talking about, could be even into like hundreds of megawatts. So when we talk to the owners of the company, or at least the engineer level, or the managers level, the technical guys, they all know what to do. But the problem is when it comes to the downline people like technicians, especially when it comes to this part of the world, sometimes we are talking about engaging some not so highly educated technicians to perform the installation. This is where things go haywire. So I would say this would be also part of the common mistakes that you are seeing at the installation site. For example, you tell them to strip, I'm showing you here a real solar cable. you tell them to strip a certain stripping length. This is based on the SOP. For example, 5 mm stripping length. To the technicians, they don't care. They will just strip as much as they can and to crimp as hard as they can. To them, crimping, the hardest it is, the better it is. So this is already
it grips nicely, yeah.
Yes, and I'm referring to when you do the crimping, this is what you see, a good crimping tool. To them, they will just crimp as hard as they can. This is inside a technician mindset. I've seen this happening all over the place that I've been visiting. Ended up, the terminal has been damaged, and this posed a time bomb in the installation process.
So they're making this mistake, sorry, John, they're making the mistake even though they're using the correct tool, but not in the correct fashion.
That's right. And this time bomb is actually going to explode over the time, whereby that crimping point will have high heat and then eventually leads to a solar fire.
Okay, and how do you communicate this? I don't think many people, as you say, are aware of it. How are you reducing the risk of that happening?
Well, for me, we don't only sell our products, our components to our customers. I will take the additional step to educate our customer in terms of conducting technical workshops. This is free of charge to our potential customer or the loyal customer that we have. We will educate the engineers or even to the extent of the owners to tell them the importance of having this SOP in place, what to do, and in practical, what they are going to do. We conduct practical sessions for them. And I also got my engineers to pay a visit to their site to share with them while they are performing the installation. So this is where we are educating the industry to minimize the threat.
Well, we've got 126 participants here today, and let's just assume that none of you guys is going to overcrimp in future. We've already had that lesson passed to you. I've got some more questions, but I'd like to take some from the audience. Thank you for answering some of us directly already. But there's one here we can take live, and Mason, could you deal with this? The question is, do you recommend over-designing the voltage input of the inverter, or is it better to have higher VOC design than more strings? If you see in the Q&A, it's the last one by Anonymous.
Yes, I can see this question here. So as long as the total VOC it is below the system requirement, for example, it is maximum for 1500, right? 1500 voltage. As long as your design it is below within this range, we also recommend to connect more modules in one string there, because if you look at the inverter working efficiency at the higher voltage, the efficiency normally it is also higher at somewhere around 1200 volts. It is also higher. The efficiency is higher, which means the generation also higher. So yes, but you should design the whole. You should consider the overall VOC. It should
and
not
of course you have to
beyond
be careful with the
system requirement.
VOC, right? You must be careful with the open circuit voltage at the minimum temperature.
The overall.
Right. So that's a question to look out for.
Yes. Correct.
Okay. Good. Andrew. Trackers, yes or no? Years ago, people were just worried because moving parts always cause problems or cause more. There's a higher risk, I say, of problems for moving parts than if everything is locked down. But there are benefits and stuff. And people ask questions also about land requirements. So what's the trade-off? Are you needing more land requirement for trackers compared with fixed tilt solutions? And how does that impact the financials and the LCOE? Levelized cost of electricity.
Thanks, Christoph. So, if we use equatorial regions as an example, as at the extreme, compared to fixed tilt solutions, the panels will tend to be much shallower, as the sun's usually at a higher sun altitude angle in the sky. So, accordingly, that means the row spaces between the fixed structures are much narrower because there's not as much shading. The shadows are shorter. So what that means is when you compare the land requirements to tracking, the tracking land requirements can vary according to how widely you space the rows, right? So even if you work to what we call a ground coverage ratio of 0.5, that's really tends to be the limit in terms of how compact the rows are. Tracking will tend to require about 25% more land. And if you open it right out to 0.3, which tends to be the limit at the other end, it can be slightly more than twice the amount of land. So it really comes down to site-specific.
Can you just explain once again the 0.5 and the 0.3? What does that refer to?
That's the ratio of the width of your module collector area to the length, to the pitch to the next row.
Okay, so 0.5 means you've got as much space in between of empty land as you have of active modules area.
Yeah, essentially it's counterintuitive, but 0.5 is actually more compact and 0.3 is really widely spaced. So in a typical, in a tracker with a single module in portrait, 0.5 GCR will be an east to west pitch of, with our 550 watt modules, of about 4.8 meters. And if you open that to 0.3, then it's 7.5 to 8 meters, much wider. Okay. So the more you space the modules, the less near shading you get from the adjacent structures, the less time the trackers are spent in what we call backtracking mode at the start and the end of the day. So the more land you use, the less shading and the more energy you get. Usually there's about 5% more energy taking it to that extreme. But the trade-off is using more land. So it's been really interesting to go through this process in Asia, actually, because, you know, on one extreme, we quoted 0.5 gigawatt in Malaysia as part of LSS4, and land costs in Peninsular Malaysia are pretty exorbitant. There's no land, right, really, free land available. So that all drives the economics to go as tight as you can and minimize the land usage and take the hit on the energy. Conversely, markets like India, Australia, especially Rajasthan in India, pretty freely available land at a pretty low acquisition or lease cost. It goes towards really opening the rows out and getting that extra 5% on yield. So the usual rule of thumb is 2.5 to 4 acres per megawatt for tracking is the usual range. But yeah, even baking in that land cost, at both ends of the scale, both in Malaysia and in India, we've seen superior LCOE, lower LCOE in the order of 5 to 8%. Just yesterday, I was running the numbers on a project in Rajasthan, and we got to 8% lower LCOE than fixed tilt.
So that's a combination of how much more energy per watt and how much higher cost per watt.
Yeah, it's incredibly site specific and how much the solar resource varies, and so there's many moving parts. So if you're considering tracking or fixed tilt for your particular project, we'd encourage you to scrutinize all of these variables and work with a partner who can kind of step you through the various financial parameters that can impact your financial return.
What about proximity to the equator? I think conventional wisdom is here. We've got more clouds on the equator, less direct benefit from tracking, versus when you go just outside the tropics and you get those blue skies all day long. But I think the tracking performance improves still further. Can you give us a sense of the numbers there?
Correct, yeah. So the two reservations historically about tracking on the equator. Firstly, the wind. Markets like the Philippines, Vietnam, the eastern coast of India, even up in northern Australia, we can get cyclones, but people want the trackers to remain in situ and functioning for the asset lifetime, right? So we've run the numbers on that in the Philippines. We think maybe costs about 20% more to reinforce the tracker structure, but it does work in some regions of even the Philippines, which tends to be the most affected by wind. And again, we're still getting to around about 5% lower LCOE.
You're getting higher costs with structure. And what about the extra yield? Is the yield improvement compared to fixed as good on the equator as it is in, let's say, Rajasthan?
It tends to be the whole, going back to first principles on tracking, right? The sole intention is to, if you consider a fixed structure, the panel is only facing normal to the sun momentarily for a very small time of the day, and actually only truly normal, very small part of the year. With tracking, you can get the panel very, very normal to the sun for almost the entirety of every operating hour of every day. So by doing that, you collect, if you've got a reasonable tracking accuracy of 2 degrees, which ours certainly are, you can capture 99.6% of the direct component of the irradiance. So that means where you deploy tracking in high direct solar resource regions, you really turbocharge your yield boost from tracking. Now, when you do that in the equator, where it tends to be a bit more tropical and a bit cloudier, that relative proportion of direct to diffuse irradiance diminishes, and it can incur a bit of a haircut on the yield. Now, what we've learned is there's a synergy, what we call this value stacking approach, where 1 + 1 = more than 2, where you use bifacial modules on trackers. There's some benefits where, firstly, bifacial modules, they tend to have a pronounced uptick in more diffuse regions anyway, so it kind of ameliorates some of that drop off anyway. But then when you put the interesting thing is where you put a bifacial module on a tracker, firstly, the trackers tend to be a bit higher off the ground and more widely spaced than fixed tilt. So it allows more of this diffuse irradiance to come in and around and strike the underside of the cells and really accentuate the gains that you get from those bifacial modules than you would in a fixed tilt. Then we can do some interesting things with our tracking algorithms. So the algorithms used to be quite standard, actually. You would just program them to follow the position of the sun in the sky for every minute of every calendar year, basically. That becomes an order of magnitude more complex, where you have bifacial modules and you have to have a tracker controller that's continually going through the decision-making process. Do I keep tracking the sun, or do I go to a flat position which maximizes the diffuse irradiance pickup on these bifacial modules? So we actually employ artificial intelligence, machine learning on our network controllers that talk to all of the individual trackers. And at times of heavy cloud cover, a signal sent and propagated through the field. Every tracker sent to a flat position pretty quickly. And we're finding that kind of functionality can boost yield additionally by more than 2, and then sometimes up to 8%, which is a pretty big number.
Okay, so it sounds like you've got a lot of AI involvement here, not only for the wind and the CFD, but indeed the bifacial is going to bring many more challenges. That's interesting. On rooftops, traditionally it's been a lot simpler, the design. You can do all kinds of fancy simulations, but if you know your home market, you know you're going to get 1,200, 1,300, 1,400, depending on where you are, specific yield, so kilowatt hours per kilowatt peak. So Lim, these big modules, are you seeing also a useful market for them in rooftop applications, or are you going to also bring out smaller modules, perhaps made with those cells, with the big cells? But I see a little bit of challenge maybe in lugging those big modules on a roof. You need 2 people rather than 1. What's Trina's philosophy going to be there?
Yeah, thank you, Christoph, for the question. So yes, you are correct that for the bigger modules, especially the 500 watt and above, yes, that will be pretty big and heavy. So we are actually targeting to use this module with the large-scale utility and ground-mounted projects. So in terms of rooftop projects, especially like the smaller residential rooftop or the smaller CI rooftop, Trina has another range of product which is also using the 210 mm cell size. So this will be in a power bin range of about 390 to 400 watt with a weight of approximately 21 kilos. So this, and the dimension itself is only slightly increased compared to the previous 166 and 158 models. So we think this new range of products will be very well suited to be used for residential rooftops.
Great, so it's still roughly a 2 square meter panel in that case. because this is something important. We have a lot of beginners who say, oh, wow, 600 watt module. They compare it with a 400 watt module and they think they're getting more. And you have to explain the efficiency hasn't actually changed that much. So watts per square meter is no big difference yet. It's just that you're using fewer actual panels to do the same job. And good to know that you'll be using the same large cells, but I guess you're cutting them smaller or something to create the smaller module for rooftop use.
Yeah, we are still using the same cell size, but it's just that the number of cells have been reduced. So for our 400 watt module, there will be 40 cell cut into 3, so there will be 120 cells. Then
yes.
For the bigger ones like the 550, 600, those will be using 55 cells and 60 cell cut into half. So
right,
it's just,
so you're cutting the cell into 3 instead of into 2. So
yeah,
it's the same cell size, but smaller portion.
Yes, correct.
Okay, good way to understand that. Now to John at JG Lab. These bigger current modules, for a long time, the standard cable on the modules is 4 square millimeters, and only for long distance runs you use a 6. Are the new larger currents having an impact? Can we still get away with 4 millimeters square? Or do you need to now change the standard and supply 6 square millimeters?
Well, 4 mm square is a general requirement at the panel side. It will come up with 4. Most of the, I would say 99.9% of the module makers are using the 4 mm square at their solar panels. Then when it comes to installation, it depends on the string size, the length of delivering your current to your inverter or to your inverter room. So all this has to be taken into the account. And this is including also the efficiency in terms of, or you may say the loss, that how many percent you want to control, let's say 1% or 3%, that you want to achieve. Then with all this information, then we can come to some decision on which size to pick. I quote you an example. In Vietnam, I visited a site that from the solar panel, from the string, they need to travel 400 meters before they reach the inverter room. And with that, the customer on the spot, they have shown me some reports when I visited the site that it shows that the loss is higher because of the travel distance. All right. As we all know, the solar cables has contact resistance, and for example, 6 mm square, we are referring to 3.39 ohm per kilometer. So all these are taken into account, and then eventually, I have proposed the customer to consider a 10 mm square solar cable, because 10 mm square, we are talking about somewhere around less than 2 ohm per kilometer.
That's good. And of course, also, if you have those large ones with 1500 volts, one of the reasons the industry went to 1500 was to reduce the I²R losses, so that helps as well. One difficulty people often have in going to 10 mm squared is the lack of availability of connectors. The standard connector will handle 4 and 6 mm squared, fine. Then often the connector doesn't match, and the panel manufacturers all invent their own connectors. It's very frustrating.
Lately,
how do you deal with
maybe
that?
I can put some correction on that part. Lately, there is this 10 mm square solar connectors available in the design already, and it's already in the production. So not to worry. When it comes to 10 mm square, it is the same connector like this. Okay, right. It's the same thing. It's just that the terminal, everything is the same. You can connect it to the solar panel, which is still using the 4 mm square cable size. Right. Because the mating part here, this portion is still the same.
Yes,
while the terminal is of bigger size, so that it can deliver the 10 mm square current.
Okay, so you're one of perhaps the few manufacturers that does supply 10 mm squared.
Yes.
I'd have to challenge Trina and your competitors as well to supply connectors which do that. I know often you don't have the same connector as other manufacturers, and then it must connect with the cables. And make sure, please, that your manufacturer also supplies 10 mm squared options so that we can do that. Maybe yours already do, and I'm wrongly beating you up. Any comments on that?
Yeah, I think no, we do recognize of this different kind of cable sizes in the market. So overall, I would say that it's still very much on the project dependent. So depending on the overall design, the layout, how you are running the cables, and like what John has mentioned, the losses that you want to take into account, then we might consider some kind of maybe some kind of customization going forward to help to manage this whole higher current kind of modules.
So in other words, if someone's doing a very big project requiring long cables, they concluded they need 10 square millimeter cables, then they can ask Trina to make sure that you supply the panels with connectors that are compatible to a 10 square millimeter manufacturer.
No, I cannot give you a definite yes here, but I will say that definitely no, we will work on a case-by-case basis and also work closely with all our partners and customers to see how we can manage this.
Okay, good. Thanks very much for that. Mason, on the inverter side here.
Yes, yes.
Yes, I'm just checking you can hear.
Mm-hmm.
On the inverter side, do you have any issues with the connectivity? So with the connector standards,
if we launch the new inverter,
yeah,
it's standard there. Yeah.
So for you, it's not an issue. You can take in 10 millimeter square, 6, 4, anything will fit.
Yeah, we only take care of the currents for our inside our inverter there.
Okay, thanks. Sorry, I have to occasionally mute because we got a lot of thunder coming in my neighborhood. I'm not sure if that's rumbling background sound here. Let me see if we got any more questions from the audience. I know a lot of them have been answered online. It's a question about, well, here you go. It's a fairly generic one. While we've got Mason, how do you select the Huawei inverter model with a solar panel? Is there a generic guideline there? Or it doesn't really matter?
Pardon?
There's one question. How do you select the Huawei inverter model with a solar panel? It's maybe almost too simple.
Project by project, case by case, loading. Yeah, that's you can connect to us. Okay, we can, based on your project, we can, and the location, we can give you the solution there.
Okay, so maybe it's less, the actual panel itself is less relevant and more the overall system size. Okay, good. Back to, let me see here, I got the one. Back to the module manufacturers. Yes, the module manufacturing. So maybe one of the unintended consequences we're seeing here of the larger cells. I started out at the beginning that all manufacturers were originally, for about 10 years, using a very similar cell size, which meant panels were a very similar size, which meant the glass manufacturers were churning out more or less the same size. Now, there are longer lead times. Some people are frustrated and they're blaming the glass manufacturers for putting up their prices, partly because a lot of the bifacial panels are requiring glass and glass, so you've got double the glass volumes per watt required. And also because suddenly you need such a variety of different glass sizes. Is this a real issue or just a temporary aberration? How does Trina see that developing as you transition to the new large cell modules?
Yeah, thank you, Christoph, for the question. This has been, I think, the supply chain issue has been a very hot topic in these recent months, particularly over, we can see, shortage of raw materials ranging from glass to the cells to some other parts of the components, which has, I would say, directly or indirectly, so-called rise some of the prices now for the solar modules. But I think moving forward, we do see that probably by early half of next year, we should have some comfort to this supply issue. And probably by second half of next year, I think the whole supply chain will become very stable again, with sufficient supply in terms of these raw materials to all the module manufacturers.
Right, back on, now the thunder's gone. Time-wise, we need to start wrapping up. We've had a lot of good coverage here, seeing that the new large format panels, I think, are definitely here to stay. Trina is one of the leaders in changing the dimensions. Others are also following. So it's not just one company standing out on its own, but the whole industry going in that direction. We see that the inverter manufacturers are also stepping up and retuning their portfolio to match these new higher current modules. And of course, the connections and cables are playing a very important role and seeing what they need to deal with to handle the higher currents. I'd like to ask each of you to just very quickly, because we don't have much time, and I'll go in reverse order, to give perhaps a summary of your thoughts of today's discussion. What thought would you like to leave with the audience? Mason, could you start? And then we'll go to Lim, to John, and to Andrew. Mason, over to you.
Okay, so yes, thanks for all the panelists here, okay? And thanks, Trina, for this webinar here. I think if you look at the solar project, the LCOE is dropping very fast. And you can see the technologies also, it is changing very fast to support on the same. So I would say, looking at the solar industry, it is very promising there. So let's embrace more innovations from the modules, from the inverter, and from the cables, connectors, from the whole system here. Yeah, thank you.
Lim, over to you.
Yeah, thank you. I think thank you, Christoph, and also the other panelists, and Mason for giving a good summary. So I think from my side here, my last comments will be, we should always embrace innovation. Do not be afraid, to look at the higher power modules and how it can help you in your system. We are always open for discussion and how we can help each other to achieve the lower LCOE for your projects. Thank you.
Very good point there, because you're dealing with an industry which is always nervous about change. Is it proven? Will it work? But of course, without innovation, we don't make progress. John, could you please give us your closing comments?
Thanks, Christoph. Well, I always share this with my customers or whoever that has been asking me this question. You see, for connection system, I'm referring to the DC side. Put aside the AC side. The AC side is mainly referring after the transformer, all right, or after the inverter. Then when it comes to the DC side, the cost of having this part of the connectivity is always less than 2% of the whole total cost. And unfortunately, there are many customers that keep trying their best to lower down the cost, to cut the cost. And no matter how you cut this part of the cost, the maximum that you cut is 2%, not more than 2%. So let's say you cut 50% of what you should spend, it means you only cut 1%. So the problem is connectivity is the weakest part in the entire solar system. And if you are not taking care of this weakest part, it means you are asking for a problem to arise in your whole installation. And I always call this a time bomb, because you won't know what is going to happen within the next 3, 6, or 9 months. Yes.
That is a very important point. And we all say that solar, the module manufacturers are giving 25, sometimes even 30-year warranties on their equipment. And you're right, 2%. If it's zero, if you give it away for free, they're not saving much, but they could be having basically a bad end of a bargain. So good point, well taken. Andrew, you've got the final 30 seconds pretty much, so tell us.
Yeah, we're just thrilled to be active in so many exciting and emerging markets that are going to reach gigawatt scale in Asia Pacific very shortly as the energy demands continue to grow. And, you know, with tracking delivering 15 to 20% more energy for you and a lower LCOE, you know, we're really thrilled that we are at a point now where we're making tracking viable in markets where it was previously perceived to not be viable.
That's, yeah, very good. The LCOE coming down. It's remarkable how in the last few years, compared to 10 years ago when solar was still seen as something that needed subsidies, today it is undercutting coal, undercutting gas, undercutting nuclear. I think for a lot of other industries, they're sitting up and paying attention that solar and indeed wind and a few other renewables are the way to go. And I think that's good news for everybody. Let me thank all the panelists on behalf of our participants and also on behalf of Terrapin. Thank you for inviting us for this webinar. I hope the participants found it useful. And Paul, can I hand back over to you for the closing ceremony?
Thanks very much, Christoph. And thank you, of course, to Andrew, John, Mason and Lim as well for sharing your insights. Definitely lots for everybody to unpack in there. If you would like to listen to any of it again, don't worry, we'll be sending you an email tomorrow with how you can download the webinar or watch it on demand. So please keep a lookout for that. Also,
will those slides be available that John showed?
We can make them available.
Okay, typical question.
Sure. I think just one other thing for us from my side here at Terrapin is we are launching a new digital solar event in May next year. We're going to be taking a look at the Asian solar market in a virtual event. So if anybody would like to get involved in that, please do contact me directly or contact any member of the Terrapin team. We'll be sending more information in the new year. In the meantime, I know it's only early December, but just want to wish everybody a restful, festive season. I'm sure if you're anything like us, you're pretty exhausted after this year, so please do have a good break. And we really look forward to reconnecting with all of you guys in the new year. So thanks on behalf of myself and the Terrapin team. Thank you very much for joining us.
All right. Bye-bye, everybody.
Thanks, guys.
Merry
Bye-bye.
Christmas.
Thank you, everyone. Thank you. Bye-bye.
Thank you. Thank you. Bye.